right, guys, this is day 1 of our Unit 5, which we are doing all on Classroom. So you are going to definitely work through this day 1 video, and if you finish before the end of class, start day 2. I am going to do my best to remember when to tell you to pause the video and either work by yourself if it's a page that says solo, or with a partner if it's a with a partner slide, and I think I labeled all of those too. Also make sure that you are completing the notes that are going to be glued into your notebook, or you are just writing down in your notes depending on what the slide says to do. So on this first day, this first lesson, we are talking about exploring the magnitude or the size of numbers, and we are also talking about how we can express very large or very small numbers using what we call scientific notation. And as we are going through this first lesson, I want you thinking about this essential question, which says, how can exponents help us to write very large or very small numbers efficiently? So what we will do in this lesson is look for some patterns in powers, talk about exactly what scientific notation is and give you a working definition, sort some examples and non-examples of scientific notation, and we'll finish out with some practice. This we went over in class also, but I just want to say again, you should definitely make it to the end of day 1 by the end of today. If you finish, please continue in Classroom to the day 2 post. And please hold yourself accountable. The only way that this type of learning is going to work is if we are all trying our best to stay on track. So that being said, the very first thing you are going to do is, this one is a solo, so you can see the icon up here. And you have this sheet to glue into your notes. I want you to go ahead and pause the video, and I want you to complete this paper to the best of your ability. I also want you to record in your notes anything that you notice or wonder about the data that is in front of you. So I want you to go ahead and pause the video now. I'm actually going to just stop talking for a few seconds so you can pause the video to complete the paper, because I will put up answers in a second. Did you pause the video? Okay, so hopefully you've restarted now, and let's look at what you had as compared to the answers that you should have gotten. And at this point, you should have been assigned a partner by Ms. Brennan or Ms. Hawkins or Ms. Parlapiano. And so the rest of this lesson you can do with your partner. So looking at patterns, the part that wasn't filled in for the most part is in red, and except for the fraction notation, which is in black, but the parts that were not filled in before are also up here. So I want you to notice what's happening, at least especially with the positive numbers. We have this pattern of 10 to the first power is a 1 followed by 1 0. 10 to the second power is a 1 followed by 2 zeros. And that pattern kind of continues for all of the positive numbers. It doesn't look quite the same for the negative numbers, so you may have noticed that already as one of your notices or wonders, that this 10 to the negative third power didn't have 3 zeros, but it did have 3 places past the decimal point. You should have written down some other things that you noticed or wondered. And at this point, if you are sitting with your partner and you're thinking, oh, I still have a question that I really want to get answered that isn't cleared up by these answers, I want you to go into Classroom and click on the link for the Padlet. There's going to be a different Padlet for every day, and during the first few minutes of class tomorrow, we'll spend some time going over the questions you had on the Padlet. So if at any point you have a question, please try to be as specific as possible, and it would also help if you would reference what slide it was. So if you just tell me this is the self-check page, then I'll know that you have a question on that. All right, so let's talk about what scientific notation is. So back here, we see that we have exponential notation. So exponential notation would be a power, in this case, of 10, followed by either a positive or a negative exponent. And we have decimal notation, fraction notation. When we get into why we use scientific notation, Scientific notation is very convenient for these numbers, especially down at the bottom or the top of the table that are very large or very small. And how we write scientific notation is, hold on one second. So scientific notation looks like an expression that shows a number that's greater than or equal to 1 and less than 10 that is then multiplied by some power of 10. So I want you to pause the video so that you're able to record this exact definition into your notes. And actually, never mind, that's on a handout paper. This chart is set up in your notes as just 2 lines. I want you to record, once we get into these examples, an example that meets criteria and does not meet criteria for scientific notation. So take a second to write down the definition. All right, now I'm going to drag a few examples out from behind the definition. And the first one that I have is 145 times 10 to the 5th power. And automatically what I noticed is, oh, I've got a power of 10. So that's part of my definition, multiplied by a power of 10. I'm multiplying. That's another thing that I noticed about this particular example. However, it's 145, which is not greater than or equal to 1 and less than 10. So we would write that in our non-examples column, or it does not meet criteria. So if you want to use this one as an example, that's great. The next one is 4 times 10 to the 3rd power. So again, I notice I have a power of 10. I'm multiplying, and this 4 definitely falls into that range of greater than or equal to 1 and less than 10. So this one meets criteria. Now, before I explain, I want you and your partner to talk about what is the problem with this one. I'm telling you there's a problem, so find it. So if I'm looking at this example, I see I have 9 and 999 thousandths. So that's between 1 and 10. It's less than 10. I have a power of 10. I have 10 to the 2nd power, but I'm adding. And so by definition, this does not meet criteria. So if you found that problem, good job. Let's look at another one. Maybe. Okay, again, pause the video and decide with your partner where this one's going. So I have a power of 10. This is the first one where it's a negative power of 10, which is absolutely fine. And then I have multiply. The problem is 7/10 is less than 1. So this one would be another does not meet criteria. Let's see if we can get one more. Okay, same thing. Talk to your partner. Is this a meets criteria or does not meet criteria? So go ahead and pause the video. All right, this one I see 3, which is good. That's greater than or equal to 1, but less than 10. And I have multiplying. But I have times 8 to the 3rd power. And we're going to get into practicing with a base that's not 10, but that's not today, because today we're only talking about scientific notation. And scientific notation has to be multiplied by a power of 10. So that would go over in the does not meet criteria column. So before you go on to the next slide, make sure you have 2 meets, or this meets criteria example down, and 2 of the does not meet criteria. All right, guys, so at this point, I want you to look at the notes that I gave you on how we write numbers in scientific notation when they're not, when they're in what we call standard form, and then how we write numbers in standard form when they're in scientific notation. So if you look at those top 3 examples, they are all in standard form. Those are numbers how we are used to seeing numbers written. And if you look at the bottom 3 examples, that is what you just learned to be scientific notation. So based on the notes that I gave you, you don't have to copy those down. They're already on your capture sheet. I want you to go ahead and try this with your partner. So pause the video and try to practice converting between those 2 forms. So when I'm writing numbers in scientific notation, and I don't know if I said this, but you need to just write these examples in your notes. I'm assuming you took care of that. When I'm writing numbers in scientific notation, I need to first start with a number that's greater than or equal to 1 but less than 10. And so if I'm looking at this first example, I need a decimal point right here instead of where it's currently at, because I need that starting number to be greater than or equal to 1 but less than 10. and we're multiplying it by some power of 10. And at this point I need to say, well, how many times do I need to move that decimal point over in order to make it so that this number in standard form was between 1 and 10? And if I count, I had to move 1, 2, 3 places. Now, because my starting standard form was a tiny decimal that was smaller than 1, it's going to be a negative exponent. But you can think about that like, well, if I was going back the other way and I multiplied by 10 to the negative third power, that would mean I was moving my decimal 1, 2, 3 points to the left, and that would get me right back at where we started. This middle one, I hope you recognized as a trick question. So we have a number already that is between 1 and less than 10. So I don't have to move the decimal place at all. So what number goes here as an exponent? The tricky part would be a lot of people are inclined to say 1, but 1 would mean, well, I moved the decimal 1 place. 0 would mean I didn't have to move the decimal at all, which this is not really working to show that. So this should be 0. And think about it, 10 to the 0 power, or anything to the 0 power, is just the number 1. And so this is saying that 4 and 382 thousandths times 1 is just itself. Last example. I hope you're seeing or predicting that the exponent in this case is going to be a positive because we're starting out with a really big number. So we have 17,840, and I need to make that a number between 1 and 10. So it's going to be 1.784. Now let's talk about how many places did I have to move that decimal. It started out here even though you can't see it. Remember, when you can't see a decimal point, it just means it's at the end of the number. So I had to move that decimal back 1, 2, 3, 4 places. 10 to the 4th power. Working back the other way, this exponent tells us how many times we're moving the decimal. Negative means I'm moving left, and a positive exponent means I'm moving right. I like to just draw these in. So 10 to the negative 4th power tells me 1, 2, 3, 4 places. Put a decimal place there to hold it. Now I have nothing here. And I'm going to represent that nothing with these nice zeros. Because they exist, right? It's not that I actually have nothing here. Once I move that decimal point back 4 places, I no longer have 9 point whatever. I have a small decimal. So in case this is all too much for you, let me rewrite it. 3 zeros. And I need to include all of those important significant digits because they're not zeros. One thing I want to point out right now is that people tend to mess up a little bit with moving the decimal and trying to figure out a shortcut. So people tend to think, oh, negative 4th power, that means I'm going to add 4 zeros. That's not true pretty frequently, including here. I moved the decimal over 4 places. There are 3 zeros here because the first time I moved that decimal to the left, it was from one side of the 9 to the other. So there's not a place to put a 0 there. So let's do the same thing here. We are going to move that decimal 5 places to the left. Actually, never mind. I want to change this one. Sorry if you already did this. To a positive 5, just so you get to see the larger numbers too. So 5 places to the right is 1, 2, 3, 4, 5, and I have 1, 2, 3, 4 zeros. So I should have ended up with 110,000. And 3 times 10 to the 0 power, remember we talked about this? 10 to the 0 power is 1, and 3 times 1 is 3. This is the end of day 1. So if you finished early, please feel free to continue to the day 2 video. Also, don't forget that you need to leave all of your questions on the Padlet that we will discuss the first few minutes of class tomorrow. And we'll pick up with ordering scientific notation next.